Hi folks, so a couple things we're going to follow up from the last video on. We're going to talk a little bit about how to correctly format an Excel data sheet or an Excel data figure for inclusion in a lab report or an assignment. So a couple things you need to be conscious of is in the thing that we have generated in the last video, or just our regular basic figure, we have everything technically correct, but is not in the correct format for what we're expecting for our lab reports. A couple things that we can improve here. If you notice, these two are represented by circles, both the 200 and the 100. And that can be really hard for me to figure out, or anybody to figure out, if you print this out and hand it in as a lab report. So a couple things we can do is we can make these things a little nicer to look at. We can double click on our series. I want to make this orange one more distinctive. I'm going to click on my orange series. You know, I'm clicking on the orange series when you can see all the dots light up. So I'm going to take a second to find them all. There we go, all my dots. And I want to right click on those and format data series. And I'll go over here to my little paint bucket, go to marker, and I want to change the shape of this thing. So let's see. Marker options, I want to change the type. I want to change this maybe to a triangle. Okay, and I can change the size of that if I want. I can change the color of it. But the different shapes are easy to see, even if it's a black and white. So that's one way you can improve this. Now you can kind of tell the difference, especially, for example, if we look closely at this data, you can actually see the differences between our blue series and our orange series. So that makes it a little easier for us to print out. A couple things that we did, just processing the raw data, were just placeholders for ourselves. So for example, the title. Title we don't really want on the figure. We want to put that into the figure legend. Same thing with these linear equations. And so those are really just placeholders for our. So what we're going to want to do is get rid of those, but we'll put them into a figure legend. So I have this thing all ready to go. I'm going to go ahead and copy this into Word. Okay, just going to go into Word. I'm going to drop it into a blank document. All I did was, right click, copy, go into Word, and I'm just going to paste it in. Now, the nice thing about Word is you can process a lot of the Excel stuff within Word straight away. And so, for example, I might want to center this in my for my lab report, and I'm also going to want to maybe put in a figure legend, and I need to do that for all of my figures within the text. So I have my figure in here. It's centered. Everything is looking good. I might also want to draw in a custom text box. So I've gone up here to insert. I'm going to do text box. We're just going to do a simple text box, and I'm going to draw that and put it below the figure. Now, if you see this text box, it has a black line around it. Don't like that. And so you can go up here to shape outline and just put no outline. That's nice. You still can reshape it. So I'm going to put it the same width as my figure. And I'm going to start naming this figure correctly. So this is the first figure in my report, figure 1. And my title from my curve, or my thing from Excel, my figure from Excel, I'm going to put down here as my first sentence. So I'll say calibration curve for blue dye with path check function on. Okay. So that tells you exactly what this curve is. It's a calibration curve for blue dye with path check on. So now I can get rid of that. And it'll clean my data up and make my figure look a lot nicer. And it'll help us to see some of these clear distinctions between our data sets that we would like to see. So now I want to add a little bit more. I want to get rid of all this other stuff. I want to get rid of these lines. So I can say a key takeaway here. Both the 200 microliter and 100 microliter data sets were similar in both slope and intercept, with linear equations of y equals 18.044x plus 0.01 for the 200 microliter data, and y equals 17.696x plus 0.0099 for the 100 microliter data. Both the 200 microliter and 100 microliter data sets exhibited excellent linear fit with R squared. You can get this R squared, you can either go into font and change it, or I have a little superscript button in my toolbar. You can also go into font and then check superscript. So that's an easy way of getting yourself a little more professional looking. R squared values of 0.9995, which is up here, and 0.9994 respectively. The R squared in there too. Now I don't want that superscripted anymore, so I'll uncheck that. Equals, and I have to, it looks like I have to put it back. Okay, so now calibration curve for blue dot path check on. It's okay, I'll ignore that. Both the 200 microliter and 100 microliter data sets were similar in both slope and intercept, with the linear equations of 18.044x plus 0.001 for the 200 microliter data and y equals 17.9696x plus 0.0099 for the 100 microliter data. Both the 200 microliter and 100 microliter data sets exhibited excellent linear fit, with R squared equal 0.9995 and 9994 respectively, indicating good, or indicating accurate dog linear. Accurate pipetting technique. And this is just an example of what you might have to do for a figure legend. Key things I like to have in mind are important data. So I have my linear equations and my R squareds down here, and then kind of a takeaway message. So we've had indicating accurate pipetting technique. Error bars, remember, are our estimate of precision, and you can see error bars are also quite small, indicating excellent precision. Now, the reason I have so much stuff in my figure legend is because a lot of people, when they're reading papers, will just look at the figures and the legends without actually reading the text. And since this class is meant to train you in technical writing, you have to get used to writing very informative figure legends, because a lot of people are just going to read the figures. So now I have this data down here, my linear equations. I can go ahead and delete these off the curves, off of my figure. And there we have a nice and perfectly formatted figure with lots of white space here. The data should stand on its own, and a nice descriptive figure legend with all the information you would ever need included. Okay, so I'm just going to go ahead and save that as. Let's see, I'll just get that into my desktop. And I'll name that figure legend. So you guys can do that same thing when you turn on any kind of figure. You want to be sure that figure legends go below figures. There's also going to be times when you have table legends, and table legends always go above the table. So those are things you should keep in mind. Figure legends always below the figure, should have all the data, the title of the actual graph, and that should all replace things that used to be placeholders on the actual figure. So I hope that helps. Feel free to ask questions if you have them. Thanks.